In this video, we'll start defining functions in Python. Functions in Python, like other languages, allow us to abstract away details from subtasks into separate code sections. So by the end of this video, you should be able to create Python functions and recognize the implications from Python being passed by value. Okay, on the left we have C code for an absolute value function. Notice that it tests to see if the input value is less than 0, and if it is, it makes the value positive. As a result, it returns the absolute value of the function parameter val. Here's the equivalent Python code. There are lots of similarities functionally, but let me point out the differences. First, def is a keyword to denote that you're defining a function here. The first line overall says that you're defining a function, myABS, which takes an input value variable val. Notice that neither the return type nor the type of the input parameter are defined. This has some advantages and disadvantages. The advantage is you don't need to write a myABS function for ints, another for doubles, another for floats, and so on. The disadvantage is you could try to call myABS and pass it, say, a string, and that could cause problems. There may also be some issues with the expected return type, but we'll revisit this in a few minutes. For now, let's see how this runs. So this code will print the value 7. We define the myABS function just like we did before, and now I'm printing the output of that function when we use -7 as an argument to the function. The absolute value of -7 is 7, so this works properly. Now let's look at that example I mentioned before. I'll try to pass the function the string hi as an argument. In a typed compiled language like C or Java, the compiler would have caught the type mismatch, and we wouldn't have been allowed to pass a string to a function expecting a numeric argument. But in Python, this problem doesn't come up until runtime, when Python can't find a way to compare a string to an int. And when I try to run this Python code, this is the output that we get. All right, let's do another example. Here I've changed our function to print the absolute value of the parameter instead of returning the absolute value. What do you think will happen when this runs? This is a bit tricky, so pause, take a moment to think about it, and come back. You may have predicted running the code would produce an error because we try to assign x to be the output from the function, and this new function doesn't return anything. But it turns out that if a function doesn't return anything, it effectively returns none in Python. Since we can assign a variable to none, this code still runs just fine, though you may have wanted x to have had a value, not none. All right, one more of these. What do we think this code will do? Again, pause, think about it, make a prediction, then we'll talk it through. The output here is 7. If you guessed 8, don't worry. This is a really common misconception. Let's talk this through. First, x is assigned the value 7. This translates to a variable x being created, which points to an integer object with a value of 7. Next, we'll call the Python function increment value. Increment value is given x as an argument. So when we call inc val, a new variable val is created. Val is going to point to the same int object as x. This is what we mean by copying the reference, or copy by value. Val and x are not the same variable. Val is just a copy of the pointer, which means it points to the same thing as x. Now let's look at val being assigned to be val plus 1. This operation will cause val to be reassigned to point to a new pyint object with a value of 8. Notice x hasn't changed here at all. When the function inc val finishes, the temporary variable val, which was created just for the function, will go away. Now we're left with just x. So when we go to print x, we're going to get back the value 7, which is just what we would expect. If we called a function on the variable val, rather than having it reassigned with the equal sign, we'd have experienced different behavior. Specifically, if you change the object pointed to by val and x, both would appear to change since they point to the same thing. We'll do an example like this later. For now, let's do a couple more practice problems with functions. We'll get to that soon.